Okay, so here's a real quick video to show you what this decimal activity looks like. Throughout this whole activity, we're going to be working with these squares. They're called geoboards. You guys worked with geoboards in the past. Remember, they're just these little boards. They have little pins, and then you would stretch rubber bands around on them. These ones obviously are digital ones, so they don't have the pins and the rubber bands. But you can think about it just like doing the same thing. To stretch a rubber band from one, you just grab one of these little dots and you can drag it to any of these little pins on the board. Obviously, you can't go in the middle of a pin. It'll only go from the pin to a pin. So originally we were given it set up just like this. And it says drag the blue point to create a line segment that is longer than 1 unit. Try to create a segment you think none of your classmates will. Okay, so I'm going to just show a really simple one, right? If I'm just trying to go longer than 1 unit, so from one pin to the next pin is 1 unit. So what they're giving me is a line segment that is 1 unit. If I spun this down, this would also be 1 unit, right? Up and down is 1. And just so we know, if I go straight across like that, this is not 1. This is longer than 1, right? Straight up and down is 1. Straight side to side is 1. And then this is going to be longer than either of those. If I was to like swing this around in a circle, right, it would go longer than this pin down here. And same with this pin over here. So so you can't go diagonal. Diagonal is not 1. So anywhere along here that's bigger than 1 unit works, right? So a really easy one, you can just drag it one pin longer. This is 2 units. 2 units. So put one on here that you think nobody else in the class will do. These next 4 slides, we're just going to be comparing these red and blue side lengths. Right? Line segments. I'm sorry, not side lengths. So when they're straight across, straight side to side, straight up and down, you can just count them, right? Because we can just count from pin to pin. So I'll let you do that one on your own. Sometimes, though, they won't be straight up and down. Like this blue one is not straight up and down. And remember, we can't just count these across like this. So this up and down one I can count. That's going to be 2, right? It's 1, 2. This blue one, however, we're going to have to do something to figure out how long that is. And what we'll do is we'll use the Pythagorean theorem to figure out just how big this or how long this blue line is. So what you do is you put in this right triangle by going straight side to side, straight up and down. And I could have just as easily went below the line. It doesn't really matter. And then we're going to build the squares off of all 3 sides, just like we did in the previous unit. So square. I went off the screen a little bit here, right? So let's go like that, square. And then we'll have one more square coming down over here. And if you remember from the last week's learning, we found out that these 2 little squares add together and equal this big square. So to figure out the area of this smaller square, this one right here, so its side length is 2, and since it's a square, it's going to be 2 by 2. So you take 2 times 2, or 2 squared, which is 4. So this is going to be 4. And to find the area of this one, this is 1. And since it's a square, this side length is going to be the same. So 1 times 1, or 1 squared, is 1. And then to find the area of the big square, we just add those 2 numbers together. So 4 plus 1 is 5. And last week, I still was talked to a few different students who were making the mistake of forgetting to take the square root from time to time. So remember to always take the square root. So the area of this big square is 5. So to find the side length here, we take the square root of 5. So hopefully we've done enough of these that we recognize that that's not a perfect square. So it's not going to give me a perfect number, right? So we're just going to estimate it. So remember, this red one was 2, right? 2 units long. This blue one is the square root of 5, right? And the square root of 5, if we plug that in my calculator or looked on my square root chart, we would find out that it's about 2.2, right? And 2.2 is bigger than 2, so the blue one is bigger. So I showed all of the work on this one. If you had other ways of thinking through that, that's okay. But remember, the idea is to be able to know how to use the Pythagorean theorem at the end of the day. So you're going to do that a couple more times, exploring these line segments using the Pythagorean theorem. Here it says, here's a line segment one student created. Use whatever tool you want to find the exact length, and then hit submit to check your answer. So when we check your answers, they're going to be looking for exact answers, which means we're going to have to enter square roots. Remember, to enter square roots, you just type in the letters S, Q, R, and then when I hit T, this is going to turn to a square root symbol. Okay, so that's how you enter in exact answers, by using these square root symbols. And then here, you're just trying to create the longest possible line segment. Pretty straightforward. Here, you're just going to be creating 3 line segments. So you're going to create the red one to be somewhere between 2 and 3 units long. The blue one should be 3 to 4 units long. And then the purple one just has to be longer than 4 units. And then after you've created what you think this line segment is, you enter in the exact lengths down here. Again, if it's a non-perfect square root, like we did the square root of 5, you're going to have to enter that as the square root of 5 to make it exact. Here, just read through this, answer this question. It's pretty straightforward. And then here you're going to create a line segment that's exactly 5 units long. Okay. Now, if you try just to go straight side to side, you'll notice that these boards are only 4 units long, right? 1, 2, 3, 4 units side to side. And if I went up and down, it's going to be the same thing. 1, 2, 3, 4. So you're going to have to try to figure out how to create a slanted line segment that's exactly 5 units. Okay, so I'll let you kind of explore through that. Remember, basically what we're looking for is we're trying to figure out how to create a square that's exactly 25 units squared, right? Because the square root of 25 would be 5. So think about how you could do that. And then this last screen, this is an extension. You don't have to do this screen. If you want to challenge yourself, try hard things, then I would tinker around on this and try to figure out this problem, but you don't have to. Again, if you have any questions, make sure you email me, and I will try to answer those in an email.